Way out past the familiar glow of the 8 planets, in the cold, dark frontier of our solar system, lies a huge, frozen collection of cosmic leftovers. But this isn't just a junkyard. It's a time capsule, one that perfectly preserves the wild and chaotic story of our solar system's creation. To unlock the secrets of our past, we have to journey to this remote place, the Kuiper Belt, and decode the origin story written in ice. This isn't just a tale about distant, frozen worlds. It's the story of where we came from. To really get a feel for the Kuiper Belt, you first have to appreciate its staggering scale. Our journey there means leaving everything familiar behind. We pass the rocky inner worlds, cross the great divide of the asteroid belt, and fly by the colossal gas giants, Jupiter and Saturn. Then, we venture into the blue, frozen territory of the ice giants, Uranus and Neptune. Here, at Neptune's orbit, about 30 times farther from the Sun than Earth, we reach the inner edge of this immense, donut-shaped region of space. This is the Kuiper Belt. It's a structure so vast it's hard to wrap your head around. While it often gets compared to the asteroid belt between Mars and Jupiter, the Kuiper Belt is a monster in comparison. It's about 20 times wider and holds significantly more mass. It stretches from Neptune's orbit at 30 astronomical units, or AU, out to about 50 AU, and a scattered population of its objects continues for hundreds of AU beyond that. Inside this colossal area, there are hundreds of thousands of icy bodies larger than 100 kilometers across, and likely millions of smaller ones, all leftovers from when the solar system was forming. For most of human history, this entire region was just a theory. In the 1940s and 50s, astronomers like Kenneth Edgeworth and Gerard Kuiper speculated that a belt of icy objects might exist beyond the known planets. They figured the early solar system wouldn't just stop cold after Neptune. There had to be some debris left over. It was a brilliant bit of cosmic detective work, though Kuiper later came to believe that Pluto's gravity would have scattered these objects, leaving the region empty. It would take decades for technology to catch up, but finally, in 1992, astronomers David Jewett and Jane Liu found the first Kuiper Belt object since Pluto, a tiny body now called Albion. That discovery opened the floodgates. Suddenly, the solar system was much bigger and a lot more crowded than we'd ever imagined. We had found our solar system's attic, a dark, frozen region filled with forgotten relics, each with a story to tell. To understand why the Kuiper Belt is there, we have to rewind the clock, way back. We're talking 4.6 billion years ago, before the planets, when our solar system was just a giant, rotating cloud of gas and dust called the solar nebula. As this cloud collapsed under its own gravity, it sparked a star at its center, our Sun, surrounded by a spinning, dusty disk. In this disk, the story of our solar system began. Close to the hot, young Sun, only rock and metal could solidify. These particles clumped together bit by bit over millions of years to form the terrestrial planets, Mercury, Venus, Earth, and Mars. But farther out, beyond a point astronomers call the frost line, it was cold enough for things like water, ammonia, and methane to freeze into ice. With all this extra icy material, much larger planetary cores could form. These cores grew massive enough to pull in huge atmospheres of hydrogen and helium gas, becoming the gas and ice giants. For a long time, we thought the planets formed right where they are today and pretty much stayed put. But studying the Kuiper Belt shattered that peaceful picture. It revealed a past filled with unimaginable violence and chaos. The most accepted theory today is called the Nice Model. It suggests that the giant planets, Jupiter, Saturn, Uranus, and Neptune, were actually born much closer together and nearer to the Sun. For a while, things were relatively calm, but then Jupiter and Saturn, the two biggest giants, drifted into a powerful orbital resonance, where for every 2 orbits Jupiter completed, Saturn completed 1. This resonance was like a huge gravitational shove, and it destabilized the entire system. The orbits of Uranus and Neptune were thrown into chaos. Computer simulations show them getting flung outwards in a dramatic and destructive journey away from the Sun. Neptune, the outermost of the giants, plowed into a dense, primordial disk of countless icy bodies that lay beyond its original orbit. Its immense gravity acted like a cosmic snowplow, scattering these small worlds in every direction. Billions of them were hurled inward, some captured as moons or asteroids, while most were ejected from the solar system entirely. This gravitational rampage was the defining event of our solar system's teenage years, a game of planetary pinball that totally reshaped the architecture of our cosmic neighborhood. When the dust, or rather the ice, finally settled and the planets found their current stable orbits, the outer solar system was a shadow of its former self. Models suggest the original disk of material out there might have held 7 to 10 Earth masses. Today, the Kuiper Belt contains just a tiny fraction of that. Most of the original material was lost, scattered to the far reaches of interstellar space. But what's left isn't a uniform field of debris. Instead, it's a complex, structured region, a fossil record bearing the scars of Neptune's violent migration. Looking at the Kuiper Belt today is like investigating a crime scene. The evidence of Neptune's rampage is everywhere, etched into the orbits of its inhabitants. We can divide the Kuiper Belt into a few distinct groups, each telling a piece of the story. First, there's the scattered disk. These are objects that were thrown into wild, unpredictable orbits by Neptune. Their paths are highly eccentric and tilted, taking them high above and far below the plane of the solar system, sometimes hundreds of AU away from the Sun. These objects are still being nudged around by Neptune's gravity to this day. Then you have the resonant populations. During its outward journey, Neptune's gravity trapped many icy bodies in special orbital patterns. The most famous of these are the Plutinos, a group that includes Pluto itself. They are locked in a stable 2/3 resonance with Neptune, meaning they complete 2 orbits for every 3 Neptune makes. This cosmic dance keeps them safe, preventing them from ever getting too close to the giant planet. The fact that these resonant groups exist is one of the strongest clues we have that the planets really did migrate. But maybe the most precious region of all is the cold classical Kuiper Belt. The term cold here doesn't mean temperature. Everything out there is unbelievably frigid. It refers to their very stable orbits. These objects are on neat, nearly circular paths that lie flat with the rest of the solar system, almost as if nothing ever happened to them. They are thought to be a pristine sample of the original protoplanetary disk, a population that somehow survived Neptune's chaotic journey, relatively untouched. These objects are the real time capsules, holding the most primitive, unaltered material from the dawn of our solar system. By studying them, we're looking at the original building blocks of the outer planets, frozen in time for 4.6 billion years. For decades, the Kuiper Belt was just a collection of faint dots in our most powerful telescopes. That all changed on July 14, 2015. NASA's New Horizons spacecraft flew past Pluto, and what was once a fuzzy point of light became a complex, breathtaking world. We saw towering mountains made of water ice, vast plains of frozen nitrogen, and even a thin, blue atmosphere. Pluto, the king of the Kuiper Belt, was revealed to be a dynamic dwarf planet, completely changing our ideas of what a cold, distant world could be. It proved that even in this deep freeze, geological activity can last for billions of years. Along with Pluto, the Kuiper Belt is home to other big players, like the dwarf planets Eris, Makemake, and Haumea. Each one is a unique world. These larger bodies are the survivors, the biggest of the would-be planets that grew to a respectable size before Neptune cleared out the neighborhood. But as incredible as the Pluto flyby was, the New Horizons mission had a second, even more profound target. On New Year's Day 2019, the spacecraft visited a much smaller, far more primitive object called Arakoth. At over 4 billion miles from Earth, it became the most distant and primitive object a spacecraft has ever explored. What it showed us sent shockwaves through the scientific community. Arrokoth looked like a flattened, reddish snowman. It's a contact binary made of two separate pieces that gently fused together. This was a huge revelation. Theories of how planets form often involved violent, high-speed collisions, but Arrokoth's delicate shape told a different story. It suggested that the building blocks of planets grew not through catastrophic crashes, but through a slow, gentle gathering of material. The two lobes likely formed near each other, and over a long time spiraled in for a merger so soft it was more like a cosmic docking than a collision. For the first time, we were seeing a snapshot of planet formation, frozen in the act. Its surface was just as revealing. Arrokoth is covered in dark, reddish organic molecules called tholins, mixed with methanol ice and water ice. These are the very ingredients that, if delivered to a young Earth by comets and asteroids, could have helped spark life. Arrokoth isn't just a rock, it's a perfectly preserved recipe for building a planetary system kept in a deep freeze for billions of years. As much as we've learned, the Kuiper Belt keeps surprising us. As the New Horizons spacecraft travels even deeper into this realm, it's detected dust levels that suggest the belt might be far larger than we thought. Recent observations from ground-based telescopes have also found a surprising number of objects beyond 60 AU, hinting at a vast, undiscovered population in the solar system's far frontiers. But the biggest mystery to come out of the Kuiper Belt is a kind of ghost. For years, astronomers have noticed a bizarre alignment in the orbits of a handful of the most distant objects out there. These objects all swing out in the same direction, on orbits that are tilted in the same way, as if they're being herded by the gravity of something huge and unseen. This has led to the compelling, though still unproven, idea of Planet 9. The astronomers who proposed the theory, Konstantin Batygin and Mike Brown, suggest there could be a hidden planet, maybe 5 to 10 times the mass of Earth, orbiting in the darkness hundreds of times farther from the Sun than we are. If it exists, such a planet would be a true outcast of the solar system, likely an ice giant core that got ejected during that early planetary chaos and settled into a vast, lonely orbit. The hunt for Planet 9 is one of the most exciting quests in modern astronomy. Observatories like the Vera C. Rubin Observatory, which is beginning its survey of the sky, will scan with unprecedented depth and might finally reveal this hidden world or rule it out for good. Whether it's there or not, the possibility is a powerful reminder of how the Kuiper Belt keeps pointing us toward the solar system's deepest secrets. The Kuiper Belt has gone from a theoretical idea to a recognized third zone of our solar system, and in the process, it has completely rewritten our understanding of our own cosmic history. It's not just a field of icy rocks, it's the fossil record of our solar system's birth, a testament to a violent and chaotic past filled with wandering giants and scattered worlds. It is the birthplace of comets and the home of dwarf planets. In the gentle merger of Arrokoth's two lobes, we see the quiet beginnings of planet formation. In Pluto's surprising complexity, we see the enduring geological life of these distant worlds. And in the aligned orbits of its farthest travelers, we might be seeing the gravitational whisper of a hidden planet. The journey to the Kuiper Belt is more than just an astronomical expedition. It's a journey back in time to the very first chapter of our solar system's story. By studying these pristine, icy relics, we are piecing together how everything we know came to be. We're learning that our solar system isn't a static clockwork machine, but a dynamic, evolving place with a dramatic history. The story written in the ice doesn't just tell us about the birth of planets. It tells us about our own origins, connecting our life on this small, blue world to the grand cosmic ballet that unfolded billions of years ago in the cold, dark frontier. If this journey to the edge of our solar system sparked your curiosity, be sure to subscribe to our channel for more deep dives into the cosmos. And for those who want to support our mission to make science accessible for everyone, you can consider joining our community on Patreon. Thanks for watching.